Hi, so in this video we're going to just be continuing on, like I said from the last one, doing the similar manipulations we did with the roots of the quadratic equation now with cubic, so with highest power 3, polynomial, and quartics, which is where the highest power is 4. So just like I started out in the last one with the quadratic, we'll write out the general form of a cubic. It would be some number times x cubed plus some number x squared, some number times x, and a constant number. Right, so just notice here, because we're starting from left to right, going down in order of power, x cubed, x to the 2, 1, 0, a, b, c, d going across. So in this case, even though c ended up being c for constant in the quadratic, this time the constant term is d. The roots of this, right, if it's in factored form, will be x minus alpha. There'll be 3 roots because it's a cubic, x minus beta, and then so just like we're going along the alphabet a, b, c, d, we'll just keep going along the Greek alphabet for the roots alpha, beta, and the next letter sequentially in the Greek alphabet is gamma, which kind of looks like a Y with a curl up there. If you want to, you can just web search Greek alphabet, and delta is the next one we'll use as well. And again, x times x times x would be just monic x cubed, but to get this factor of a, we'll have that there. So we'll do the same thing where we'll divide out both sides of our equation by the coefficient of the leading term, and so x cubed plus b on a x squared plus c on a x plus d on a is going to equal this. So again, like last time, we expanded it out, so we'll do that again. So I'll start with x minus alpha times x minus beta will be x times x is x squared minus alpha x minus beta x plus alpha beta, and that whole thing is times by x minus gamma. Might need a bit more space for this. So we've got x squared times x is x cubed, x squared times minus gamma is minus gamma, minus gamma x squared. We'll do this term now, minus alpha x squared minus alpha gamma x. Next term, minus beta x squared. Sorry, that should have been minus alpha x times the negative should be, plus, and same with this one, minus beta x times minus gamma will be plus beta gamma x, plus alpha beta x, and then minus alpha beta gamma. So again, if we collect together the like terms, we've got x cubed by itself. So with x squared, we've got x squared here, x squared here, x squared here, and they're all minus. So we've got minus, and we've got alpha plus beta plus gamma, lots of x squared. Then for the coefficients of x, we've got these terms here, alpha gamma x, beta gamma x, alpha beta x. So I'm just going to start with this one, alpha beta plus alpha gamma plus beta gamma, lots of x, and then minus alpha beta gamma. Okay, so again we've got x cubed and x cubed, just one lot of each of them. So we can equate everything else here. We've got b on a is going to be equal to negative alpha beta gamma. And so you notice that this is a sum of the roots. Alpha, beta, gamma are the three roots of the cubic equation. But if you look at the next coefficient of x, c on a, oops, sorry I didn't change colour. C on a is the coefficient of x. But this is also kind of like it's kind of like a sum and a product of roots. There's some product of roots, but also sum added together. So this one in the green is called the sum of the roots one at a time. Again, like we did last time, we'll just bring the negative over to the other side. So this is called the sum of the roots one at a time, right? Because we've just got alpha, beta, gamma, right? Is alpha plus beta plus gamma, they're all by themselves, equals negative b on a. So the difference here is the sum of the roots, okay, and plus and plus, they're both positive. 2 at a time. Right, so this is all the pairs, all the different combinations. So alpha and beta times together, plus alpha and gamma, plus beta and gamma. Right, and that's the only possibilities, right? Even if you did them beta times alpha, beta, right, that's the same thing, just in another order. So they're the only possibilities you can have. That was the coefficient of x, so that'll be equal to c on a. And then the constant term d on a here, right, this is our constant term without x there. So if we just look at this as well, again it's negative alpha beta gamma equals d on a, so we just want to pull the negative over to the other side. So this is still just called the product of the roots. The product of the roots alpha beta gamma is negative negative d on a. So sum of the roots 1 at a time, 2 at a time, and the product of roots, this is for a cubic equation where the highest power is 3. Okay, so I'll go through question 1 now using these. So I'll just write out a polynomial. We've got p of x is 2x cubed minus 5x squared plus x minus 1. So the coefficients, because they're in order, you should check. We've got x cubed, x squared, x, and a constant term. So a is 2, b, the next term is negative 5. This coefficient here is 1, and that's negative 1. So part I is just find all these three different things, and then part II and II will be manipulating them. So for the sum of the roots 1 at a time means alpha plus beta plus gamma, and that equals negative b on a, which here is b is negative 5, so negative 5 on a is 2, which is 5 on 2. Then the sum of the roots 2 at a time means where they're all paired off like this is equal to c on a. So c is 1, on a is 2. We're done. And the product of the roots alpha, beta, gamma is negative negative d on a, which is negative, and d is negative 1. Negative 1 on a is 2. So negative 1 is a half. Okay. So part II, alpha plus beta plus gamma all squared. Well, alpha plus beta plus gamma, we actually already have that expression. Alpha plus beta plus gamma is 5 on 2. So all we need to do for this one is, once we've figured out all these three different expressions, this one we can just plug it in and square it. So that one wasn't too bad. The next one, alpha plus 1, beta plus 1, gamma plus 1. Right, so we don't have alpha by itself, beta by itself, and gamma by itself, so we can't add 1 to them and then times those three things together. So what should we do? Well, maybe if we expand out the brackets, we'll end up with some of these expressions that we do know. So if I just expand the first one's alpha times beta plus alpha plus beta plus 1 times 1 is 1, and that whole thing times gamma plus 1. Now if we times all of them by gamma, we've got alpha beta gamma plus alpha gamma plus beta gamma plus gamma. And then if we times them all by 1 plus alpha beta plus alpha plus beta plus 1. So notice here we've got alpha beta gamma, the product of the roots. If we group these up, we've got alpha gamma plus beta gamma plus alpha beta, and that's the sum of the roots 2 at a time. We've got alpha, and we've got beta, and we've got gamma all by themselves, and then we've just got the number 1 at the end, right? So I'll just highlight these to all match up. We've already got yellow, alpha plus beta plus gamma, so we've got 5 on 2. Sum of the roots 2 at a time, right? This guy here in green, so yeah, it's plus a half, and the product of the roots was a half, so we've got that there, or plus a half, and then at the end of all that, plus 1. So what's that? Altogether we've got half plus a half, 1, 2, plus 2.5 is 4.5. Right, so if you don't immediately see the sum of the roots 1 at a time, 2 at a time, or the product of the roots, you're going to have to do something to make them appear, right? So if it's sets of brackets, you might want to expand them out. Like we did in the last video, if there's a fraction, you might want to find a common denominator, and you might need to do, like the square one in the last video, a bit more complex manipulation. Okay, so the next, that's for cubics, so now we're going to look at quartic, which is an x to the power of 4 function. So where's my notes? Okay, so here again we'll start at we've got x to the 4, so just going down the powers, plus cx squared. And since it's to the power of 4, there's going to be 4 roots. So x minus alpha, but again we need that coefficient out the front of the same as to get x to the 4. X minus beta, x minus gamma, and then the next letter along in the Greek alphabet is delta. Kind of something like that. Again, if you want to look up the Greek alphabet, do that. If mine looks a bit dodgy. So I'm not going to go through the exact same process we did for the last two. For one reason, it's going to be more and more complex each time we add an extra term, right? This one back up here, if I scroll back up, this was already starting to get pretty messy and long as it was. That's only going to be compounded, right? So the squared had how many terms? I think 4. This has 1, 2, 3, 4, 5, 6, 7, 8 terms. I think if we add another times everything, right, that's your cubic one there, times it by another 2, there's going to be 16 terms, right? It's not even going to fit straight across the page. So that's one reason, is just not laziness, but okay, laziness. The other one is because, like any good mathematician, we want to notice a pattern. So I said this, you don't have to learn these, right? Because, oh sorry, I thought I had this up. You can, the cubic ones are already on your, there you go, formula sheet. Sorry, I just went into advanced because it's the same formula sheet for extension 1. Right, so if you look here, right on the left side, functions here underneath where the quadratic formula is, you've got this. It says for a cubic equation which equals, so a cubic equation in general form that equals 0, it says alpha plus, right, the sum of the roots 1 at a time is negative b on a, the sum of the roots 2 at a time is c on a, and the product of the roots is negative d on a, which is what we just did, right? So I'm just going to, for starters, I'm just going to rewrite them out there so I can scribble over the top of them. So we had alpha plus beta plus gamma equals negative b on a. We had, well, let me move this over. Then 2 at a time we had alpha beta plus alpha gamma plus beta gamma equals c on a. And we also had alpha beta gamma equaled negative d on a. Right, so you might remember in the last video I said you can learn the one for for a quadratic, but you can kind of get it out of this one here, right? The one on the formula sheet is here for cubics. So notice if you kind of just block out everywhere you see gamma, right? If we just don't look at gamma, there's a gamma gone there, there's all the gammas gone. Well, if you'd with a quadratic, there wasn't a gamma, there wasn't a third root, there was just alpha and beta, 2 roots. And so if you kind of visually just ignore everywhere where there's a gamma and look at it, well look, you've got alpha plus beta, the sum of the roots is negative b on a. Then you've got alpha beta, the product of the roots for a quadratic is c on a, right? So if you just visually ignore the third root gamma, then lo and behold, this is the pattern, this is the values for the sum and product of the roots of the quadratic. So then once we introduce gamma, what happens to this sum? Well, we also add gamma onto it, and we get the cubic one, right? So just like the transition from quadratic to cubic, we added the extra root, was still negative b on a, right? Well, if we add delta onto this, the other root for the quartic is also going to be negative b on a. Alpha plus beta for the cubic plus alpha gamma plus beta gamma is the sum of the roots 2 at a time with C on A. Well, the sum of the roots 2 at a time is still going to be, for a quartic, is still going to be C on A, but we've just got some extra 2 at a time sums, right? So we've got all these combinations, but with delta. We've got delta times alpha, delta times beta, and delta times gamma. Makes there's 6 terms there that are the sum of the roots 2 at a time, right? For a cubic, alpha, beta, gamma, there was only 3 roots there. So this was the product of the roots, right? But just like going down, we've got sum of the roots 1 at a time, sum of the roots 2 at a time. Well, when you've got 4 pronumerals, you can combine them in a few ways to get 3 things. So this one actually becomes the sum of the roots 3 at a time. But there's a couple ones to think about. There's alpha, beta, and gamma, but then there's also, you've got alpha, beta, and delta. And so then both of these have alpha, so then if you remove alpha, you've got plus beta, gamma, delta is the other one. So this actually becomes, they're the only 3 possibilities you can have. So that's the sum of the roots 3 at a time, right? So then finally the product of the roots will be all 4 of them multiplied together for a quartic, alpha, beta, gamma, delta. And if you look at this pattern going down, you've got B, C, D. What's the next letter? E. They're all over A, over A, over A, over A. And also notice they're changing negative, positive, negative, positive. Right? So that's all the different expressions connected to the roots of a quartic equation. Right? So you can look at the, again, this would be very difficult to kind of rote learn, memorize all of this. You've got, you can start with these and kind of just tack on delta to all of the ones on the cubic, and then introduce an extra one, and these are all the ones you can use for a quartic. Okay, so I'll try and do 2 using this now. So we've got our polynomial is x to the 4 minus 2x cubed plus 7x minus 3. Now before we even look at anything, I just write this out when we're working with a polynomial. Write it out as, so you can see every single power of x. X cubed, well there wasn't an x squared term in here, so that's 0 lots of x squared plus 7x minus 3. Alright, that'll just make sure you don't get mixed up and go, oh, these are the values, the coefficients A, B, C, D going along, right? You need to look at these. A, B, C, D, E are connected to, in order, the coefficients, right? So, of the powers reducing. So this is A, B, C, D, E. Right, so we'll write them all out. A equals 1, B equals negative 2, C equals 0, D equals 7, E equals negative 3. Right, so if you wanted to find the sum of the roots 1 at a time, right, you'd do alpha plus beta plus gamma plus delta. All 4 of them would add up to negative b on a, negative negative 2 on 1, which would be 2. Right, and so you could find the sum of the roots 1 at a time, 2 at a time, 3 at a time, or the product of the roots. Now, this question doesn't have any scaffolding stepping you along saying, I'll find them all first, right? So we might not need all of them, and it's going to be maybe a bit cumbersome to kind of write out all, particularly this the 2 at a time term, to write them all out. So what we might do is just manipulate the expression first, right? The fractions, and then see which one of these we actually need need to use, and then just find those ones rather than all 4 of them. Or if you want to, you can just find all 4 of them. But I'm going to try and be a bit more efficient, so I'm just going to fiddle with this equation and then see which ones I need to find. Okay, so we want to get a common denominator for all of these, right? So let's just start with one pair of them, right? Let's try and get these first 2, just like I did with the quadratic, to have a common denominator, right? If you cross multiply these ones, you'll get alpha plus beta on alpha beta plus 1 on gamma plus 1 on delta. Now with the next 2, if you cross multiply them, right? Alpha beta times 1, that's alright, and gamma times alpha plus beta, you're going to have to expand. Alpha gamma plus beta gamma plus alpha beta all over alpha beta gamma, and then we've still got plus 1 on delta. So again, maybe you can start to see the pattern emerging, right? If we cross multiply these, you've got alpha gamma delta, alpha gamma delta plus beta gamma delta plus alpha beta delta plus our new one up here, alpha beta gamma all over alpha beta gamma delta. So notice this one here. Whoop. I need to do that. Right, so this one, the numerator is the sum of the roots 3 at a time, and the denominator is the product of the roots. So rather than finding all 4 of the different expressions, we'll just find these 2. So if we look back up here, we've got the sum of the roots 3 at a time. Oh, I only did 3 there. We're missing 1. We've got, actually they should all be written down here. Alpha beta gamma, alpha beta delta, beta gamma delta, alpha gamma delta, sorry. Alpha gamma delta. So we're really using actually combinatoric knowledge from our last topic. We should know that there's 4 possibilities, because, sorry, is this being dragged over? Fix that up. There should be 4 possibilities because there's 4 letters, right? Alpha, beta, gamma, delta, right? There's 4 and you're choosing 3 of them. If you do 4C3, 4 letters, alpha, beta, gamma, delta to choose from, and you choose 3 of them, then there's 4 different possibilities. Likewise, actually, if you want to check that how many of these terms there should be for the sum of roots 2 at a time, we've got 4 letters, alpha, beta, gamma, delta, and you're choosing 2 of them, and that should be 6, hopefully. That sounds like Pascal's triangle, 1, 4, 6, 4, 1. Yep. So that would be a way to check for like a higher order one. If there was a quintic, so quin for 5, then the sum of the roots 2 at a time would be, well, there's 5 letters and you're choosing 2 of them, so there'll be 5C2 many terms. Anyway, so the point of that was the yellow one is the sum of the roots 3 at a time, which is negative d on a. So this will be negative d on a all over alpha, beta, gamma, delta is the product of the roots, which is e on a. Okay, and then now it's just a matter of subbing in these values. We had negative d is 7, on a is 1, on e on a is negative 3 on 1, which will be 7 over 3. Right, there's that problem done all in one screen for you. Okay, well that's it for this video. Alright, good luck. Bye.